Hey, Matan, thanks so much for taking the time to join Scaling Robotics. Before we start, do you mind just introducing yourself?
Yes, absolutely. Good morning. Thanks for having me. My name is Matan. It's a Hebrew name in case you were wondering. I currently serve as the COO for Rebellion. It's a dual-use hardware software defense company. We serve both commercial users and DoD type customers. But more relevant for our conversation today, I spent the last decade or so scaling hardware-heavy robotics, industrial automation solutions between startups, scale-ups, big tech companies. I was lucky enough to work on mines, border protection, ag operations, logistics, warehousing across the board. My journey starts with Airobotics. This is a drone in a box autonomous solution we built back in the day. I served as VP Global Ops and GM for Americas, which means that I did the supply chain, manufacturing, field services, everything, revenue teams, and some of the reg work. I moved on to Fielden, ag tech company that does IoT and robotic devices for large ag enterprises, and then moved over to Amazon. I led the data collection annotation effort for Prime Air. That's the drone delivery service. When the service was ready to launch, I actually led that for about 2 years. I was the head of operations for the drone delivery service. And then another short gig with the Amazon Robotics team doing deployment strategy.
Can you tell us about the fleets that you scaled across the different startups you worked at, Amazon Prime Air, Amazon Ops? Share any stats about the robots, the customers,
Yeah,
anything like that?
for sure. So obviously it fluctuates, right? Between startups, scale-ups, big tech, like Amazon is the holy grail for anyone who's doing robotics. Airobotics, we're talking about dozens of units. This is a combo of an actual box and a drone with all the sensors around it. Fielden, we're talking about IoT devices, some robotic applications, but mostly IoT, so in the thousands. Back to Amazon, hundreds of drones on one side, on the drone delivery side, between the data collection effort, testing, and actual commercial service, all the way up to Amazon Robotics. I don't take credit for any of it, but we know that they surpassed the 1 million robots in warehouse. So from 1 to 2, all the way to millions.
So you're talking about your different experiences, and something I see in the industry is for many robotics teams, it's difficult to define ROI. A lot of it's hand wavy. There's more humans in the
Right.
loop than people like to admit. So at your previous experiences, how did you actually measure ROI for your deployments, and what metrics were the real drivers?
I love this question. And the main reason I love it is because I think it was clear from my intro. I was always the operator type, right? I led some tech teams, but it was always from the operator's go to market customer lens. And that is one of the biggest questions that a lot of folks that are working on great tech are not really asking themselves. They're in love with the solution, but now when we talk about implementation, the dollar value matters more than anything. There is a reason hardware is hard, right? When we think about digital solutions, they usually scale exponentially, and the added cost for each new deployment is negligible. When you think about hardware, no, that's a different story altogether. And what I've seen a lot of teams do, back to hand waving, they're stuck with the BOM cost. I don't disagree. The BOM cost is a very big piece of how much this thing is going to be costing you, but that is not the starting point. The starting point is you must understand the actual problem you're solving, because the ROI is not to you as a company, it's to the customer. Are you replacing a human with your solution? How many humans are you replacing? Are you just augmenting a solution? Are you unlocking a capability that they could not have performed in the past? That will lead you to whatever it is that the ROI number is for the customer, not for you when they consider it. Once you have that number in mind, and once you have an understanding ballpark of how much your solution is worth, now you get to double down into, okay, what does it actually cost me to operate it? When we think about the cost of operations, sure, BOM is a big piece. One thing people are not thinking about is depreciation of the equipment. How long is it going to stay in the field? You got to load that up. Next thing, that's where people don't really usually spend their time. How much are you spending on travel? Think about field technicians that are actually dispatched to go to the customer site to make the system work. How long are they going to stay there? How much are you paying their per diem? What is your mean time between failures? How many times do you need to ship spares? What do you pay on logistics? What do you pay on customs? Right? Not everything is made inside the continental USA. You got to ship things in or out. How much do you pay for that? How much do you pay for downtime? Is that part of your clause with the customer? The main thing to think about it here is that this is no longer a technology solution. This is an implementation of an operation. You got to think like an operator when you're looking through the dollar value lens of your solution.
So we're deploying a robot to a new site. We're deploying some industrial automation to a new site. What's the playbook for shrinking that
Mm.
time to value down as low as we can? We talked about some of those financial pieces. How do you think about shortening the payback cycles as well?
The first question you need to ask yourself is how repeatable your process is. The question is not how well your robot is performing in the lab. The big question is how well is it performing in the field in an unseen environment, right? Have you reached that cookie cutter stage where you know exactly what you're going to do time and again and again? In most cases, and that goes back to the mindset, it works great in the lab and then it goes to the field and it breaks, right? Another example from Airobotics, the drone company. It worked great. And then we went to Western Australia to work with miners. It all broke apart. Weather pattern were different. RF was different. Even power was different, right? 220 versus 110. All of these field inputs that you're just not seeing in your lab or in your test site, they matter a lot. And I'm not saying that you don't have to cross that chasm. You always do. And that thing takes time. You just have to call it by the right name. This is not commercial deployment. This is early stage. This is early adopter phase. Maybe call it a pilot. The point is that you don't want to rush into a commitment to a commercial engagement before you know you've seen enough variations of what real world operations look like. When you get there, that's when you start creating your process. When I think about the process, it's very different from what we think about when we consider test or dev. This is where SOPs kick in. This is where field deployment kicks in. This is where support engineering versus dev engineering kicks in. You remove them, you remove the bottlenecks, rinse and repeat. It's a classic operations. Um, Recommending again, go back to Lean Six Sigma, right? They solved it years ago. These are the practices that you have to implement when you're getting ready for that.
So, you spoke a little bit about Six Sigma and things like this. What are some of those resources, learnings, theories that operators need to know, need to have in their back pocket whenever they're deploying robots?
This is a great question. It's going to make me feel very old now. If you go into a room with a bunch of older operators and they ask you, where's the Herbie? You look across the room and you say, okay, who knows what we're talking about here? This is an oldie and goldie, very old book. It talks about manufacturing. It doesn't even talk about tech, but it goes back to that theory of constraints. And when I set up an operation and I need to identify the bottleneck, back to Herbie, that's the Boy Scout in that story. How do I actually work around it? And how do I make sure that my process solves it and moves the bottleneck or removes it from the process? It goes back to these theories. So read the goal, go back and polish up your Six Sigma practices. Think again about the theory of constraints. That's all that it is. You're working on cutting edge technology, but you're actually implementing a decade old practice of running an efficient operation and continuously improving it.
Obviously, robotics companies care a lot about how much uptime do we have, how reliable is our hardware. How do those things change the ROI curve? And in general, what are those inputs that you're thinking about to say, this is how we can keep ROI really high for our customers?
So hands down, the biggest cost driver is humans, right? How many people need to travel? How many people need to babysit your robot? How long are they on site? How often do they need to intervene? The next thing to think about is your MTBF or your mean time between failures, the cost of parts, the shipping, the customs, the lead times for those. At the end of the day, it's a vicious cycle because low reliability kills utilization because your robot is just stuck waiting for something or your spare is stuck waiting for something. That's where it becomes tricky. Low reliability destroys ROI because utilization is low. When you stand in front of your customer and you sold them on your robot, you told them that they can do X operations per hour, X picks, X lifts, Y, whatever it is. At the end of the day, you're counting on utilization. If your system is not mature enough or not reliable enough to allow that utilization, you're stuck. You're in this vicious cycle and there is no ROI for you.
How do you evaluate site readiness when you deploy automation to a site? What are those inputs that you're considering before you decide to deploy any robots or drones?
I start with very clear problem statement. In most cases, our solutions, they're not all Swiss Army knives, but we know that they can interface with a few applications. It's not one thing that does just one task or does it well. And we can tweak it. It starts with understanding the problem you're going to be solving on site. There's that major problem, and then there is a periphery of other things that you could do. But there's really one thing that your customer is after. Make sure you understand it and make sure that you can solve it. Don't go in, do hand waving, and say, "I can give you this," when in reality they actually want that. If you can't do that, just don't bother, or go back to the drawing board and fix it. The next thing you need to understand is you need to have a real champion on site that has the authority to make decisions. And I've seen it across the board because I had the luxury of working with smaller customers, bigger customers, enterprise level customers. They all have their innovation departments and they all have ideas about technology. And whenever the robot shows up on site, everybody's super excited because, yeah, I'm working on mine, but now there is this thing here that's a sci-fi, Star Wars type thing. Great. Everybody wants to see it for the first time, but I can guarantee that about half of the folks on site want to see it fail because that's the reality of humans. Who's that champion that will be there for you, that has the authority to push you forward, that will give you the hard truth, but will also be your chaperone and be your voice with the customer that will help you push your pilot forward, just because it's not going to be great the first time around. Hell, it's not going to be great the fifth time around because there is that learning that you have to go through, and you need someone with the right authority, with the right patience, with the right relationship with you that can actually make sure that you see it through successfully rather than just wait for you to fail because then you're just wasting everyone's time.
Okay. So now we've, assessed the site, we've deployed robots. What are the early signs, first month that this deployment is going to be successful? Are there any like clear milestones that you're looking to hit, people you're looking to bring on board? Yeah, what does that look like?
To me, it goes back to whatever it is that you promised when you sold the system, right? I'm assuming there was some sort of a commercial negotiation there, and you said the system can do X, Y, and Z. The uptime will be whatever it is. The time to deployment or the time to scale would be whatever it is. That's where you start. Are you delivering that value that the customer is paying for? We need to understand that the first few, you're not there, right? The first few days, sometimes weeks, if it's unfortunate and it's your first deployment, sometimes months, it takes time to really get there. The big question to ask, are you trending in the right direction? And are you measuring the right things? And that sounds, it sounds almost too easy to do, but in reality, that's a trap that a lot of teams fall in because they're so in love with their solution and they have the tunnel vision of what they think they do, and they're just measuring the wrong stuff. The first advice here, I don't know who on your team does it, but it has to be someone outside of the engineering team. It can be a business intelligence if you have one. It can be your finance group. It can be your PM. They need to clearly set these few key metrics that matter more than anything else and be brutally honest about how you're doing. Pull that data into your Tableau dashboard or choose whatever system you're using, and daily on a stand up or weekly on a business review, show the trend and be brutally honest about how you're doing and how you're prioritizing these fixes. In most cases, from what I've seen, the issue is less about building new features for the specific robot or the application, but rather building the interface that allows this thing to deliver the right value. I'll give you one example. When we were scaling the data collection effort for Amazon, early days, right? We built a parallel fleet just for data collection because it's a chicken and egg problem, right? You want the data, but you want to launch when you're fully autonomous. So you need a sister company that just does data collection. And we build this command line interface for the operators to use. Looking at the data, we're like, okay, why is utilization low? Why is failure rate too high? And then we realized, hey, we just onboarded a bunch of operators. They're great pilots. They're not all software development folks. They don't understand how to use commands on SSH with the vehicle. Why don't we spend time building them a GUI so they can actually interface with our robot a lot better? Not a big effort, right? Simple GUI. It took us a month to build it and deploy it. And then all of a sudden you look at the uptick, at the actual successful launch rates, or the interface, or the time spent on failures. And no one was thinking about the operator. We were thinking about the actual utilization of it. You got to shift your mindset once you're there. You got to think about the tools you're providing your field folks to use and how that supports that goal of getting the value to the customer.
So speaking of subject matter experts, as engineers, as business people, we're often sitting in our ivory towers looking at metrics, writing code. What is the things that robotics engineers misunderstand about deploying robots into the real world, dealing with miners, farmers, technicians, the messiness really of the real world? What do folks usually misunderstand the most?
To me, it goes back to the scale in which you're operating, right? It's I have onesie twosies, I have tens, now I have hundreds of robots, or thousands, and let's ignore thousands for a second. Let's talk about that jump from 1 to 5, 5 to 10, 10 to 100, right? The system usually works very well at the early stage because you have the tribal knowledge, or you have the subject matter experts in your team that were there since forever, and they understand every factor of the system and they can tweak it and make it work. But then what happens when you cross a certain threshold? It could be a 10 deployments, it could be a 15 deployments. That glue no longer holds because you're relying on specific individuals that then become your bottleneck. You need to get to the point that when you're done designing, you're never done designing your tech, right? But when you're getting to that point, you start designing towards scale. SOPs, people don't like writing them, but hey, what choice do you have? Training of your new field technicians, setting up your support engineering organization, right? When you think about a dev engineer versus a support engineer, a dev engineer is an animal that likes working, or a creature that likes working on interesting problems, solve great bugs, work on great tech. They get bored easily. When you start talking to dev engineers about mean time between failures and how do you get from the 95 percentile to the 99th percentile, they lose interest. Support engineering, however, they live and breathe uptime. That's the one thing they care about most. When the system goes down, they jump out of bed in the middle of the night because they are thinking about the customer, and they're thinking about it uptime, and they're thinking about how to deploy the solutions that actually get you to that 99 percentile or whatever your target is. And that's where usually there is a chasm between great dev teams and great field teams. And you need to find that connecting tissue between the two, because rarely can folks can actually move from one to the other. There are very distinct mindsets between the two.
I remember one of the first times that you and I talked, you said something that always stuck with me, is that downtime for robots at Amazon means millions of dollars lost, right? When those issues happen, any frameworks, processes for debugging and fixing issues quickly, what are the things that you're focusing on in those moments?
So there are a few things here. When, pardon my French, when the shit hit the fan, it's all hands on deck, and we all know it, right? If there's a customer down, regardless of your title, regardless of what you're working on, you make sure that the system is up again. It's really about how far between these instances occur, because they will. That's the reality of the world we're in. Something will break down the line. It's a Swiss cheese model, right? Eventually, something will happen and things will break. Again, question is how far apart? And to me, when you think about the practices that you put in place to create that distance, we talked about support engineering, right? That's one organization that thinks about uptime, that will prioritize features based on uptime, that will push you to reliability engineering versus great new tech, right? It's a different mindset altogether. The next piece is, what does your health monitoring system looks like? Like, can you know that something is coming before the customer picked up the phone? That's the worst case. Customer's picking up the phone. Hey, your system's down. You have to know about it before your customer gives you that flag. If you can solve it before they even notice it, amazing. If there's a way for you to load balance, back to Amazon, because that's the network, right? So Let's say one side is down because whatever it is, you have a large enough network where you can load balance, and you as an end customer will not even notice the fact that, hey, your nearest delivery station or FC is down. Obviously, different scale altogether, but that's the kind of thinking. Load balancing, health monitoring, preventive maintenance. I don't know what your schedule looks like for maintenance, but then you have your preventive maintenance that you do on cycle, and it's not dependent on the life cycle of the specific part, right? The motor states that it can run for 2,000 whatever hours before it gets the maintenance. But what does the system maintenance target look like? Is it every 500 hours? Is it every 1,000 cycles? Choose, right? And do your analysis on that and make sure that you actually implement that preventive maintenance on time, which will hopefully reduce the number of breaks that will have to pull people out of bed.
You've scaled multiple fleets of drones, obviously a very highly regulated industry with the FAA. Any advice for other operators scaling fleets in highly regulated industries?
Whatever you budgeted for time and resources that goes into your reg work, I don't know if you should X2 or X5 it, but assume it's a lot worse than you think it is. And this is not because anyone has ill intent. You just need to think of it from the regulator's perspective. They see a lot of cool companies out there that are trying to disrupt the industry, which is great. But their job, back to the FAA, for example, right, civil aviation authorities worldwide, their job is to make sure that no one gets hurt because of an airborne vehicle flying overhead. So they're not in a rush to approve whatever it is craziness that you want to do. It takes time. They usually don't move very quickly. That's part of the deal as well. You have to take that into consideration when you think about your timeline, when you think about your funding, how well funded are you, and can you really last that long to make it through the other end? The next thing to keep in mind is that when you think about your use cases, you got to start with the low hanging fruit. Back to Airobotics, another example for us. When we were launching an autonomous drone solution back in 2016, 2017, we were looking for areas where we had ROI, sure, but also where we thought the regulator would feel more comfortable about what we're doing. I was able to receive first in the world FAA waiver back in 2019 in Arizona, full BV loss, flying over people at night. And you're like so proud of yourself, but then you realize you're flying over a patch in the desert. No one's ever there. If you crash, no one cares. Yes, of course, the regulator will feel a lot better about that rather than if we'd show up and say, yeah, I want to fly over downtown Manhattan. Of course, they're going to say no. So choose the low hanging fruit first. And then the last piece of advice here is about who you bring in as subject matter expert. And that's one of your key hires. I strongly suggest that you hire very slow here and make sure that you understand the credentials and understand what they can deliver for you. And also keep in mind, these individuals, they're going to be very expensive.
What breaks in the hardware supply chain as you scale from that low fleet level, from prototypes, all the way up past pilots to multi-site deployments?
It goes back to basic best practices, industry best practices. And don't get me wrong, today everything is a lot easier because it's in kits. Back in the day in Airobotics, we had to solder our own packs of batteries. We had to design our own BMS. There was nothing available out there. Supply chain was very fragile. Today, you can buy it all in kits, and we've all done it, right? We've all seen Unitree delivering a humanoid for $19,000. It's amazing. It's a lot easier. But then again, what works for test does not work for scale. And that's where I strongly suggest that you take a page out of the consumer electronics book because they've excelled it. When you look at your phone, your generic iPhone or Android choose, it's one of the most complex pieces of hardware you'll ever come across because it has the heat problem and it has the size problem, has the battery problem, and they've excelled in it because they walk through the process. They do the EVT, DVT, PVT process. They have good NPI practices in place. They do design for X, right? So design for manufacturability, design for sustainability, design for reliability. Choose, but you need to understand that this process of going from a pilot phase, a handful of robots or solutions, into the tens or hundreds, there are no shortcuts here because it's hardware and because we talk about configuration and version control. It matters a lot. If you don't bake it in early enough, then it doesn't work. One key hire I would strongly suggest you bring in place. That's a tricky one because you'll see a lot of folks from the automotive industry, for example, right? And sometimes we feel like, okay, it's slowing us down. Not what I'm really suggesting here. But then when you think about a good NPI person, a new product introduction person that understands these practices, right? How do I take something from engineering or from dev all the way to mass production and go through these gates and design that process? That's where you want to look. So think consumer electronics, someone who's built phones probably would do a good job for you there on your robot as well.
Matan, thanks again for all this wisdom. Definitely well earned, hard earned after, like you said, decade of building and scaling these fleets. To leave us off, what's one final thing that you think every robotics operator or leader should know?
This is the best time to enter this space. Either you've been doing it for a while or you're just, taking first steps here. Best time ever. My perspective, there are things that are happening right now we've been waiting on for so long. There's convergence of forces that actually make it a reality. If you don't mind, I'll just name them out as I see them. There are a few things that are happening here. Hardware is being commoditized. It's a lot easier to figure out your supply chain and actually get your parts in at a low enough cost where there's a business model behind it. Software acceleration, we can talk about the data problem still for robots, but then the fact that these models exist, robots can now attend to an unseen environment and just perform a lot better than they did 3, 5, 10 years ago. Third thing, reg is getting better. I know we discussed regulation and how hard it is, but there is acceptance. I mean, go to downtown, choose San Francisco, LA, Phoenix, Austin, now Miami, Orlando. You'll see a Waymo driving around. And for those of you that haven't had that experience of riding around in a Waymo, it's life changing. But then after a week, you're just used to it because that's just a reality. That's what we're doing. And someone had to approve it. And then the last piece is really public acceptance. And I always go back to that story because when I first landed in Phoenix, in Arizona, as working for Airobotics, that year, an Uber self-driving car hit a pedestrian and killed that person. Obviously, a tragedy, but the ripple effects of that happening were insane. Uber was driven outside the state. They literally shut down their self-driving car program after that. The public pushback on such an incident was mind-blowing. When you think about public acceptance today, and we mentioned Waymo, right? Think about the Amazon workforce. If you're working in an Amazon warehouse, all 1.3 million employees, whatever the number is, they're used to working alongside robots and they have been since forever because that's the new reality. When you look at these four forces, it's actually becoming, I struggle to say easier because it's still very hard. It's becoming easier to actually unlock value in a robotic application. Enjoy the ride. This is amazing. And don't get me wrong, digital solutions are great, but the sense of self-worth and accomplishment when you deploy a physical solution and you see it operating in the field and actually driving value, second to none.